good morning, everybody. Welcome Friday, 1st of May. Welcome to May. Good to have you here. Live maths, end of season, special, finale. I have managed to escape. There were a couple of people came knocking, tried to take me away. There was a mild altercation, and I managed to get them out of the flat, lock them out, managed to make my way back into the room. I've escaped psychiatric evaluation, and I'm here to bring you two very difficult questions. All right, they're not happy with it. The authorities have come out against it, but I resisted. I'm here. Both A-level questions. Shout out to Rachel for recommending the first of the questions. Took one look at it and just thought, oh, this is what we need in our lives. And then, second question, Soul Destroyer. Okay, probably enough chat. Yeah, we've just got, obviously, we've got an observer watching in today. We've got just observing my teaching. So that's this gentleman here called Biscuit. And he will be reporting back on my teaching skills afterwards. So just under a bit of pressure with the performance review on that one. Hopefully it goes okay. Give this video a like, subscribe, get onto my Instagram. Won't be here on Monday. I'll still be there on Monday, popping out good content hopefully. I'm going to get started on the maths. That is 2 minutes of talking is really quite extreme. I'm going to draw it. That comes under and up. Not the straightest straight line of the year. You get the point. Here's some sort of point. That's what they've said the coordinates are. They're calling that L, they're calling that C. And that's 0. Anything else to mention? Not really. They've told us the equation of C. They've told us y equals x ln x. They said x is bigger than 0. So far, just writing it out, copy and paste, nothing dramatic. Okay, ultimately, they're going to want us to find the area. So the area, as any good primary school student knows, is the definite integral between the 2 points. So you would normally think maybe I'm going to integrate between here and here. And yeah, I think I do need to analyze this before I get started and see what I'm doing. It wouldn't, would that work? You could kind of try and do that with this curve. It would give you too big an area though. It would give you the area under the whole curve. Whereas you've got that line that you really want to, you need to get the area under that line as well. I don't know, it's a bit complicated. Bottom line is, this is what I'm liking. If we just slice and dice that, in fact let's draw it a little bit stronger, then we can do it in 2 stages. We can do phase 1, find this area. Maybe I'll just kind of draw that with cross check. And then this is phase 2, this sort of dotted area. So that's the overview. I'm going to get started, and what I'm actually going to do is, do you know what? I'm going to find the equation of L. I'm going to find the equation of line L. I'll do it, and then we can discuss whether that was a nice thing to do or not. L is a normal, so, okay, differentiate, product rule, x ln x goes to ln x plus x times 1 over x, which equals ln x plus 1. Quick product rule recap over here. If you're differentiating, so if you've got y equals u and v, then dy by dx equals u dash v plus v dash u. That's the product rule. Differentiate the first thing, keep the second one the same, plus differentiate the second thing, keep the first one the same. Hi man, hi guys. Nice to have you here. Get your pen and paper out. Join me. Let's get through this today. Hope you've got enough paper. Did you buy? You got enough paper? Probably all the stockpiling of toilet paper will come in handy now, because we're going to get through a lot today. 2 or 3 rolls. So back product rule. Yeah, there you go. Okay, banged on about that enough. Not going to say more about it now. You'll have to check your product rule chapter in your textbook if you've got any more questions about that. But that's the answer. So, what's the gradient of the tangent to that line at that point? Well, we know the x-coordinate. So for x equals e, dy by dx equals ln e plus 1. Ln e goes by the pseudonym of 1. So that's just 2. So what can we say then? Let's put that in a little mild bracket. The gradient of the tangent is 2, so the gradient of the normal is minus a half. Do you get me? I'm not going to draw the tangent on here, but differentiated the curve, plugged in x equals e, which is that point there, gave me the tangent to the curve, and so the normal by the curve, just to remind you of your GCSE stuff, m1 times m2 equals minus 1. So if m1 is 2, 2 times m2 equals minus 1, blah, blah, blah. m2 is minus a half. Okay, got the gradient of that. So it looks like y equals minus a half x plus c. How do we find c? We've got a point on the line, so we can plug it in. E equals minus a half e plus c. Therefore, some have said, well, e is just 2 over 2e, right? So blah, 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 add up. So it's 3 over 2e. Cool. So the equation of the normal is y equals minus a half x plus c. Oh, sorry. Well, sorry is a bit strong, but I know what c is, so I can actually fill it in. Ugliest 3 I've seen today, but there's still time yet for the rest of the day. So, oh, just be careful. Don't play with the paper, okay? It's not, I'm filming a stream. Got that going, and right, I want to find the area of that. It's a triangle. Some have said area of a triangle, half base times height. Well, someone once gently whispered that to me as I was passing going over a bridge across a small river 4 years ago. And I remembered it ever since that day, and here it is. That coordinate's e. The height of that thing is also e. What's the width? So actually, let's find this point. And that is where y equals 0. Y equals 0. So let's just write it down here as well. Probably not the best place to write it. Y equals minus a half x plus 3e over 2. Bring that to the other side and solve it. You'd notice that what? X equals 3e. So that must be 3e. So the area of that triangle is half times, well, the base must be 2e, and the height is e. Half base times height, base is 2e, height is e, blah, 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 e squared. Tremendous. What a start that is. Ultra turbo recap. There's the curve. Differentiate it using the product rule. So it's ln x plus 1. Find out what the gradient of the tangent is. It's 2. Find out what the gradient of the normal therefore is. It's minus a half. Y equals mx plus c. Plug in the point that you have, which is EE. Sorry, can I just confirm this broadcast is not sponsored by EE. There are other networks available. I personally recommend GIFCAF. But there you go. You plug in EE and you end up with that. Yeah, c equals 3 over 2e. And what else you need to do? Yeah, find the point where it crosses, find the area of the triangle. Bob's your uncle. Halfway there, because we also need to find the area of the dot fest. We got this guy, we can even just write it in maybe, e squared. Dot fest, how are we going to get that? Well, it's going to end up actually, now being integral between something and e of x ln x. Reasonable, right? That is the area under the graph from here. So that actually is the area under the graph. If you'd done it, the whole thing, it would have given you some extra stuff here. I don't know, it would have been a bit nasty, but as long as we can find this point, integrate between that and e, that is the right thing to do. It'll get you the area under the graph. Correct thing to do. So I should probably write dx in there. And also, why don't I try and find, so really we need 0 equals x ln x, because if you recall, y equals x ln x is the equation, and it cuts the x-axis at y equals 0. What's the solutions to this? Well, it could be x equals 0. By the way, you got two things multiplied there. So it could be x equals 0 or ln x equals 0. You see what I'm saying? It's just like when a quadratic, when you factorize it, and you get two things multiplied and you say, this gentleman can be 0, or this gentleman can be 0. Could be also some ladies in there, let's not be sexist. But whoever's in there, they're equaling 0. X equals 0 is actually not going to work, by the way, as it happens in this case, because if you, ln 0 is undefined, you can't have ln 0. If anyone's got a calculator that gives you an answer for ln 0, please let me know. I'll send the police around immediately. We need to get it confiscated. It's an illegal item. It's not correct. Ln 0 doesn't exist. However, ln x equals 0, we could do e both sides, so e to the 0, so x equals 1. See what I'm saying? Exponentiate both sides, so you have e to the ln cancels each other, got x, and then e to the 0 is 1. Therefore, that point is 1. Therefore, our integral is between 1 and e of that. Okay, now it's a case of doing it. Integration by substitution, integration by parts, partial fractions, oh, what are we going to do? Oh, what is it? What's happening here? What? Integration by parts. Let's write the rule out. Integral of u v dash equals uv minus integral of u dash v. Sweet. Box it. Worth boxifying, isn't it? Who would ever begrudge a man a boxification of integration by parts? If anyone is flabbergasted, paranoid, upset, crying under the table by my use of notation here, that's du. The dash means it's a derivative. So v dash is dv by dx, if you like, and u is just, that's normal. Basically, if there's a dash, that means it's the derivative. So you could write this out in the other way. You could write u times dv by dx equals blah, blah, blah. Good luck to you, all right? Best of luck to you. I'll send you some flowers. I'm going to do it this way. Spoiler alert, key point here is with the ln ones, you might think that x has got to be u, and this is an art. You need to practice integration by parts to get slick on this, all right? But it's a bit of an art, a trick to learn it. Actually, the ln x is what you need to make the u when there's a ln. And you make the x the v dash. See what I'm saying? You've got to call one of the things multiplied u and one of them v dash. Actually, that's how you assign them. U equals ln x. Therefore, u dash equals 1 over x. V dash equals x. Therefore, v integrating x goes to a half x squared. Alright? That's my little jotting that I always do for integration by parts. Now I've got all the stuff I need. I've got u dash, v dash, or u du by dx, dv by dx, v, if that's the kind of language that you speak. And then what's happening now equals, let's just plug it in basically, u times v is a half x squared ln x minus the integral of u dash, let's just write it out in a couple of lines, is 1 over x, and v is, it looks to me like it's a half x squared so let's not integrate it yet, let me just simplify that, it'll be a half x, it looks like. Yep. And by the way, since just for notation, since I've already integrated this bit, I would usually, just to keep you guys on, not keep you guys on your toes, to keep you guy's honest and clean, yeah, I would put that in a box and say that I've integrated that between e and 1. Now let's integrate that thing. So the whole integral will look like, if I've got it right, minus a quarter x squared. Like that, between e and 1. Cool. Let's keep going for now. Equals. Putting the e in, a half e squared. Well, ln e cancel each other, so it's just 1. Minus a quarter e squared. Minus, you put 1 in, ln 1 is 0, so that goes away. And then, so you've got a minus, looks like a quarter. Watch out for that actually, because that's minus a quarter. That could be a bit dodgy. Careful just plugging your stuff in last gasp there. But okay, I think I managed to get away with that one. And you're going to end up with a quarter e squared plus a quarter. Dun, 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 dun. E squared from before. It's been waiting on the sidelines for when we got the area of the triangle. E squared from before, making a last minute appearance, dashing down the wing, jumping into the box, being added onto this, and therefore your final answer should be 5 over 4 e squared plus a quarter. I think it's plus. Yeah, should be fine. Okay, the sun is just rising and coming onto the page, illuminating the mathematical beauty in all its glory. Recap. There's the graph. Find the area. Found the area, well, split it up into 2 parts first. Found the area of the triangle. To do that, we had to get the equation of the normal. Could get the gradient by differentiating the curve, finding gradient of the tangent, flipping it, making it negative reciprocal. Y equals 0, you can find that point, blah, 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 half base times height. This little chestnut here is a normal integral. Just need to find the bounds. E was given to us because that's the point. X equals e. 1 we had to find by setting y equals 0. Doing a little bit jiggery pokery dockery here, and we got what we needed. 1. Integration by parts rule. Do it out. Your u's got to be ln x. Your v's got to, your v dash has got to be x. These are the things that you're setting up. U's ln x, v dash is x. Fill in the rest of the stuff. Plug it in, continue your onward journey via some algebra, try not to make any catastrophic errors, sneak in your e squared from the area. That's your final answer for the area we asked for. Let us put that away for now. Just double check or anything rational. Oh yeah, I didn't even check. Show the exact area is a e squared plus b, where a and b are rational number. Okay, so a is 5 over 4 and b is a quarter. And there's no drama. Rational is fine. It's fine. Rational. That's all right. It doesn't mean it has to be whole number. It just means it has to. Pi is irrational. Root 2 is irrational. Anything that doesn't stop the decimal places is irrational. So a fraction is fine. A normal fraction is fine. Okay, moving on. If you're still, if you've still got any energy, momentum, lifeblood, soul left after that, that might have been enough for you. You might need to go back to bed now. Wouldn't blame you. Good luck to you. Okay, have a nice nap. If not, get ready, because this is, and I'll be honest, this is a bit pushing it. All right, but yeah. In all seriousness, it's tough. Probably slightly above the scope of the A levels. It's definitely A level principle, but it's got extensions in it. So I'm just going to go for it, and try and have a family member watch you while we're doing this in case you pass out. They can call the services. If not, you get panic buttons sometimes. Or sometimes the Apple Watch can tell if you fall, it can automatically call the ambulance, I think. Anyway, get some sort of procedure in place. I'm going to get started. Will I just leave the question down there? Yeah, let's just leave it down there and get started. So, writing it out. It's the best part of the whole thing, isn't it? Writing it out. It's just like, get it down on paper. But, okay, you got that. Let's check I did it correctly first. All right. Sweet. Okay. Going to do something. Well, I mean, let's do something first, and then we can see where we're going. You know, they're saying find a solution to that equation. They've given us the boundary conditions. It's not unheard of that we are presented with something like this to solve. Probably the right-hand side's a bit funkier than we're used to. Probably the right-hand side is a bit dodgy. Rachel's roped in her cat, Mr. Sandman, for assistance. Excellent, Rachel. Great, thank you. I'm glad that health and safety is covered. Yeah, I think they usually are first aid trained, most of the cats, so that's good. So yeah, what I'm saying is the right-hand side, yeah, it's worse than you've seen before. Possibly. Wow, too much talking. Here's the work and it's starting. Square root of y squared minus 1 over x squared minus 1. Not done anything too dramatic, pulled out a factor from top and bottom of that thing, y squared and x squared. Well, that's nice, because now I can pull it out of the square root. So actually, I should probably put the absolute value on it, because when you take the square root, it could be negative y as well. So I'll just do that as an extra. Maybe don't worry too much about that, but oh, sorry, that would still be there. What you got, y squared minus 1, x squared minus 1. And because x and y are positive, you don't need to worry about the negative square root. So, I don't know, that was a bit of a stupid step actually. I mean, not stupid, pedantic. Put it in brackets and I'll just write what the real... You could have really just gone straight to this. X squared minus 1. Okay. It's mildly better, not winning any awards for looking beautiful, but we're getting somewhere. And so well, at least now you can do the stuff of solving differential equation. It's bringing all the y's onto one side and bringing all the x's onto one side. This is year 2 topic, so it's quite towards the end, I think, in the integration chapter, or the differential chapter, one of the last ones. So we're pushing it already, but it is there, and it says get all the y's to one side and get all the x's to the other side. So it's going to look like 1 over y times root y squared minus 1 dy equals, that x will still be there, like that. So yeah, just brought that down at the top, that whole thing, so it'll be 1 over, and also brought the dx up to the top, so it looks like that now. Cool, so now we've got all the y's on one side, and we've got the dx's on the other side. It's time to integrate. And this is, again, still, it's how you do it. It's in the textbooks. This is the story. Get the y's on one side, get the x's on the other side, and integrate. That's not the drama. The drama is more, how do you integrate this? Substitution, parts, partial fractions, reverse chain rule, guess it. Numerical methods, use a computer. Tell me, someone tell me. Help me from above. Okay, it's a strange one. It is substitution. And I guess there's maybe more than one way to do it. Sometimes there is more than one way to do it. I'll certainly show you one way that I found that works. Not badly, but it's also where the pain and suffering starts. The actual integral itself is not too bad, but it's the next phase of trying to write it as y equals where the pain and suffering really kicks in. So for now, here we go. Substitution, let's not call it y, that was a bit, wait a second, we're going to have, oh yeah, what we're going to say. Yeah, we are going to say y. We're going to say y equals sec u. Let's do it, and then let's see why that might be good. So, integration by substitution. So you need to differentiate your thing. You need to differentiate sec u. Well, that just gives us a chance. You could check your differential equation tables or something and find out what the derivative is. Gives us a chance just to practice that, though. Sec u, let's do a little side project over here. Well, I don't know what, I won't box it yet. Don't know how long it's going to take. Sec u is, so if y is 1 over cos u, right? Sec is cos. Yeah, 1 over cos. So you could use quotient rule. So let's do that. Call the top one u, call the bottom one v. And so for quotient rule, dy by dx equals u dash v minus v dash u over v squared. Like I said, you can look up this derivative sec. I just can't remember what it is off the top of my head, but probably is out there. Good thing is though, you don't need to. You don't always need to carry the information around with you. You can just bust it out if you need to. Here we go, busting it out. So looks to me like u dash would be 0. Well, I just write them out actually. U dash equals 0 and v dash equals, what's the derivative of cos u minus sine u? So 0 top minus v dash, so that would be minus sine u, and u is just 1. So minus sine u. And on the bottom you've got v squared, v is cos u, so that's going to be cos squared u on the bottom. So minus is plus. That's got a sine over cos as a tan, and a 1 over cos. So it looks to me like, just double check it yourself if you want, tan u sec u. That is the derivative of sec u. Again, you could have, or sec x, sec theta, call it what you want. That's me showing it. It's like a little sub question. It's like a little side part. I mean, you just didn't even pay. You're not even paying for this. This is extra. And I've used quotient rule to differentiate sec u. Tan u sec u. Writing down my findings. Then I'm going to write that suggestively like this, which is what you do with substitution. You know, multiply the u up to the top there. And now I can begin the long, arduous, well, maybe not that long, exaggerating process of subbing that in. So you'll get 1 over y sec u. Sec squared u minus 1 times tan u sec u du. We're on to a new page, don't worry, so there's not much life left down there. But that's it, I'll have subbed stuff in, so that's the integral. I should say, by the way, the dx and dy are the same, so I'm just doing it for dy now, but it's a 2-for-1 special offer in Sainsbury's. Whatever I get here is going to be the same answer over there. Anyway, plugging my stuff in, y is sec u, so sec squared. Changing my dy to du. That's what the point of doing this little thing is. That's worth a little micro box, because that's always another, that's the sort of side project you have to do every time with substitution. It's the overarching theme of substitution. You can do a substitution, you can change your y to something else if you want. Not a problem, you can do that, but you pay a penalty. Penalty you pay is you also have to change the dy. And this is how you do it. You change the dy to du. There's the conversion rate. I'm not sure if that's good against the dollar or the pound as a conversion rate, tan u sec u, but you have to stick it in there. Next page. Tidying that up then. What can we do? Okay, let me just convince you. Cos squared x plus sine squared x equals 1. Divide everything by cos squared x. So 1 plus tan squared x equals 1 over cos squared x. And so tan squared x equals, well, 1 over cos is sec, so sec squared x minus 1. So this bit is tan squared x. So we've got integral of 1 over sec u tan u, because it will go to tan squared, and then you take the square root. I'm just saying that quite casually, but for me, that is lovely. Cancellation, cancellation. Going a little bit mad now, but that's the kind of thing that happens when I just see that integral of 1. So the whole thing has actually, via substitution, simplified to, let's do the integral of 1. And, well, Biscuit, my cat, can certainly do that. I think probably some of your 3-year-old nephews could as well. So that's just going to give you u. There is a plus c, of course, but that's quite nice. That's quite nice. So going back to the equation then, because this is where we were at, really, in some sense. Well, no, it wasn't a side project, but just good to remember what we're actually doing. We're integrating both sides here. We've worked out that by substitution, the integral of that is equivalent to the integral of 1, which is just u. But there is a substitution, and I should probably sub it back in, because we said, remember, y equals sec u. So how are we going to sub that back in? Well, you're going to have to do, this is where it gets traumatic, u equals sec to the minus 1 of y. It's like inverse sec. Whew. So I can sub that back in. Sec to the minus 1 y plus c. Writing the whole thing out, sec to the minus 1 y equals sec to the minus 1 x, because it's the same on the other side, plus c. So we're not over, we're not finished, but let's take a moment to really just be happy with what we've done with our lives. We were given that, all right? We're not the biggest fan of square roots of things to the power 4. You know, we joined a couple of fan clubs back in the day. We sent some fan mail, but since then our emotions have dwindled. We're not delighted. We did factorize a little bit, taking out the y squared and the x squared, bring them outside. Looked like that. Then we brought all the y's to one side, and we brought all the x's to the other side, because that is what you have to do to solve differential equations. Now we have to integrate. And how do you integrate? It looks like it could be partial fractions or something. It's got two things multiplied at the bottom. I would not sit here and blame any man, woman, child, or guinea pig who tried to do partial fractions here. As it happens, probably wouldn't work that easily. If you somehow notice, or with experience or whatever, and maybe the question might say to you, if the question said to you, you know, use the substitution y equals sec u, then you've got no excuses. There it is. Differentiate it using the quotient rule. Sub all your stuff back in, so you've got it in terms of u now, and you find, also remembering that tan squared is sec squared minus 1, that it all cancels, and you're just left with integral of 1, which is u, plus c. Just remember though, you did your substitution y equals sec u, you got your answer as u, that means you have to put it back in. Unfortunately you can't put the y back in, so you're going to have to write it as u equals, and it's inverse sec. So actually, in a way, that's the end of it, that's the answer, that's fine, you've solved the differential equation. But being the pain merchant that I am, and the suffering that really enjoy wreaking upon the nation, I chose this question because it wants a little bit more from you. It wants you to write it y equals. This is definitely beyond, so I think you might even, you could keep your pen and paper out, but I wouldn't blame you for relaxing now, chilling, just guiding yourself towards the end of this. I'm going to have a sip of tea, certainly. Anyway, I'll take a new page for it. Oh, just attacking you. There's just been a mild earthquake here. Biscuit's okay, don't worry. So, Yeah, let's just write out again. Sec to the minus 1y equals sec to the minus 1 x plus c. There might be more than one way to do it. Just watch this though. If I do cos of both sides, alright, so cos of sec minus 1y equals cos of sec to the minus 1 x plus, oh yeah, we need to find c actually yet, don't we? I didn't even get to that yet, sorry. So let's go back and find c. Well, they gave us initial conditions for it. They said that when y is 2 over root 3, then x is 2. I'm not going to explain in too much detail this one because we don't have time, but you'll if you looked at it, you'd notice that that's true. If you just flip what's inside here, it turns to cos. Since it's 1 over sec, actually the impact of it is, if you want the inverse cos, you can do 1 over what's inside. So don't worry, let's not worry too much about that aspect, that's a little bit trickier. Anyway, it's good for us because we know 3 over 2, that's a known value of cos, and I think that one is pi over 6, isn't it? Yeah, as in 30. Yeah, that's right. And cos of a half inverse, again, you can check your calculator for this, but it should be 60, which is pi over 3. And that means that c, 2 pi over 6, should be minus pi over 6. So there you go, c is minus pi over 6, just by subbing in. Quite funky, don't worry too much. Quick rule there is, if it's inverse sec you're trying to find out, you can flip what's inside there. In a minute I'm going to draw something that might help you see how you might work that out. Don't worry about it too much now. So it wasn't actually a plus in the end, it was minus, and it was minus pi over 6 was our c. Okay, I'm continuing. Cos sec minus 1 y equals addition formula. Cos of sec minus 1x times cos of pi over 6 plus sine of sec minus 1x times sine pi over 6. Because, no, I'm not going to write it out, you get that in the formula sheet. Cos A plus B equals cos A cos B minus sine A sine B. If it's the other way around, if it's cos of A minus B, it's cos A cos B plus sine A sine B. Can simplify some of that stuff. Cos pi over 6 to cos 30. Well, we kind of just did it, it's root 3 over 2, isn't it? And sine 30 is a half, so you should have that. Okay. Take a breath. Take a breath, I'll take a sip. What are we going to say? Well, let's have a look at it like this, and then I'll kind of explain what I'm doing. Going back to what we said our substitution thing is. Sec minus 1 equals theta. We'll call it theta instead of u now. So, well, actually we'll call it x as well. So that means that x equals sec theta, of course. So that is x equals 1 over cos theta. So cos theta equals 1 over x. So this is a little thing I did, and it's kind of using the same substitution. Sec to the minus 1 x equals theta. Sec to the minus 1 of something equals, so, this theta is sec to the minus 1 of something. If you mess around with that, you see that's equivalent to cos theta equals 1 over x. Which is helpful because I can then start to draw a little triangle. So cos theta is 1 over x, then that means the adjacent must be 1 and the hypotenuse must be x. That means I can also find this thing here with Pythagoras would be x squared minus 1, square root. And so sine theta would be opposite over hypotenuse, x squared minus 1 over x. Okay. Let's see. And so cos of inverse sec, yeah. Okay, and therefore this is quite helpful for us because I said theta is sec inverse of x. So if I sub that back in, really, I've ended up showing that cos of sec of minus 1x is the thing that equals 1 over x. And sine of sec minus 1x equals that. So I really do hope your parents and guardians are on standby, your animals, your babysitters, guinea pigs, because that was tough stuff. And should I recap now or recap later? Tell you what, I'll do a quick subbing back in and then I'll recap what I did there. And it's alright, I wouldn't say you should look to understand every inch of this, and it does become a bit more traumatic when you start to deal with inverse sec and cosec and these kind of things, cot. But right, I'm going to sub it back in. So you'll get 1 over x equals, so what's that one? Oh, actually, sorry, that would be 1 over y. Let's just scrap it again so it looks nice. 1 over y equals cos of inverse sec was, well, so that would be 1 over x times root 3 over 2 plus a half, and we worked out what sine of sec inverse 1x is, which is that thing. Okay, recap. Integrated. I'll not recap that part again, but we use substitution. We use substitution y equals sec u, and when you did it, the answer came out as inverse sec u plus c, or inverse sec y plus c, sorry. So integrating, where was it? Integrating that guy here gave us that. So that was possibly tough enough already. You probably did go to hell and back to get that, but I was saying that's not enough. I was actually saying I am not satisfied with your performance. I'm going to fail you for your year-end mock unless you get that in y equals. So this is where really, there's probably more than one way, like I said, I don't know. I mean, you could try and do sec to both sides, and that would undo that, and then you'd get y equals. Just might look a bit dodgier on that side. I don't know, there's different ways you can now try and get this y equals. This is quite a nice one though. If you do cos of both sides. Here's a good example, by the way, of when you do an operation, you have to do it to the whole side. You can't just do it to each individual thing. Oh, by the way, I found c was negative pi over 6. Just to mention that. But anyway, so it's like if you square, if you square one side, you've got to square the whole of the other side. You couldn't just do the terms individually. So that's fine. Cos of all of that equals cos of all of the right-hand side. Well, right-hand side is addition formula. It's two things. So that minus that. Addition formula, cos A minus B is cos A cos B plus sin A sin B. Expand it out. No one's going to say that's easy. This is a test to you. Can you expand things out nicely? Not panicking about that sec x being there. Sec x inverse, it's an item, but it probably could cause fear, alarm, panic, and trauma. Anyway, you expand it. Some of the stuff you know. I mean, sine pi over 6, that's sine 30, that's a half. Or at least your calculator knows it. Same with cos pi over 6, that's known. Then you just need to find an expression for this. Alright, and then I use this as absolute, I would call this kind of the box of tricks. This is my magician's box of tricks here. So if we call the angle inverse sec, like that. So we draw a little triangle, call that theta and say it's inverse sec of x. Rejig that by sec both sides, blah blah blah. So that must mean x is 1 over cos theta, or cos theta is 1 over x. Then I can start filling in my triangle. So I've got it in terms of cos theta. I know SOHCAHTOA. I attended my GCSE schooling from 9 till 4:30 Monday to Friday through all my formative years. Therefore, if cos theta is 1 over x, that means the adjacent must be 1, and the hypotenuse must be x, because cos theta is adjacent over hypotenuse. Pythagoras will give me the other one, and I can use that other one to find the sine, because sine theta is going to be opposite over hypotenuse. And by the way, the whole premise of this was that theta equals the inverse sec, so I might as well sub it back in. Therefore, I've come up with two equations. They don't look the part. They're not going to win any beauty pageants. However, it's exactly what we needed, because we've got the cos sec inverse, we've got the cos sec inverse, oh yeah, the same one, and we've got a sine sec inverse. Sub them in, you get to that. Not much remains really. It's just a case of tidying it up. What are we going to do? Times everything by 2y. So you get 2 equals, what would you get? Root 3 over x times y plus that whole thing over x times y. Bringing things to conclusion. Come on, let's do it. Sprint to the finish. It's a marathon. And you've saved a little bit of energy reserves for the end. What can we do? Times everything by x. 2x equals root 3y plus this stuff. Pull out y as a common factor. Root 3 plus and divide by this thing. Just write it y equals 2x over root 3 plus root That's money. That's in the bank. You can cash that. There it is. Bish bash bosh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I let it go again. Y equals, that's the solution to the differential equation. Probably, no, I think there's been enough turbo recaps. You've been through hell and back. Well done for sticking with it. Thanks very much. I'm happy. I'm satisfied. You know, I'm pleased. I've made you suffer. And it's a bit like Monsters, Inc. You know, your scares and your fear is what I feed on. So I'll be able to, probably won't have to have any lunch today off the back of that. Thanks very much, guys. Any questions about that, you can let me know. I know that was a little bit monstrous. This is just a little trick thing. There's probably other ways you could learn to convert an inverse sec into a normal y equals thing. The idea of inverse sec is a bit weird anyway, so that's alright. But it's there, it exists. If you're going to do maths at uni or anything to do with harder maths courses, it's good to try and get a grasp of doing algebra with these kind of things. Thanks very much for watching. Have a lovely weekend. Catch you guys soon.